Dry versus wet code. What does that mean from a best practice perspective? And more importantly, what does it mean for us infrastructure people when managing our favorite infrastructure as code? It's all coming up, but first, play it! Hey everybody, and welcome back to the channel. Before we get started on today's episode, please go ahead and hit that subscribe button. It really helped me out and helped me grow the channel. And also hit that notifications bell so when I do upload a little bit of content, you're just notified. You can click on it and give it a like and a share. That'd be amazing if you do that, by the way. So yeah, like and share as well, please. Thanks very much. So with that out of the way, let's get back to today's topic. So what I want to discuss with you is dry versus wet principle and how that can impact us as infrastructure people developing solutions in Bicep or Terraform, and really just trying to carry that best practice forward really and make our lives a lot easier, because I have seen some developments and they are a little bit, very wet. Yeah, and it's not good. And it's not good for particular reasons. So when I say wet, I mean write everything twice, or you could write it a million times really. And essentially it's all around, from our perspective, it's all around hard coding values, rewriting things that we don't need to. You've got a big main.tf, you haven't created any modularity within your development, and it's really just hard to take control of. So even from a readable perspective, you know, you've got hundreds and hundreds of lines to read through. You've got fixed values in there, hard-coded values. So I've got to change it once, I've got to change it 20 times, 30 times, 40 times. And it just gets wildly out of hand. And then that can also lead for room for error. So when we think around copy and passwords, for example, I know everybody's done it that's watching this, so don't lie. But you miss things off. You might miss, the end value off. You might have a space at the end of it, which you've got to delete and go back. And that inconsistency, that room for inconsistency can lead to errors. And then you're then less efficient because you've got to sift through all of this infrastructure as code, trying to find this value or this error because you think you've got it right and you've copied it right and you've pasted it in, and it's just an absolute hassle. So makes bug fixing horrible. And as I mentioned before, scaling, yeah, it's all right maybe for the test environment. So when you're testing that functionality and you just want to deploy something within Azure and you think, right, that's brilliant. I can, for example, deploy a VNet, a subnet, a Bastion server, a virtual network, a virtual machine, and I can RDP to that. Brilliant. At least I know it's working. So, but the purpose of that deployment wasn't done for best practice. It was just testing functionality. So then when you move it to production, you'd want to be tidying that up and then operating under best practice. So it's all well and good in a testing environment because it's quicker, it's simpler. You haven't got to do that extra legwork to, plug in variables or, a bunch of other stuff. You're only testing the functionality. So in that respect, yeah, wet can still apply because it's small and it's for only testing purposes. Whereas when we try and transfer that over to production, and then you've got other components in there, it can quickly get out of hand, become unmanageable, and just be a headache for you managing it moving forward. And then potentially teammates managing it or handover scenario, nightmare. So yes, wet probably still has its place in a testing environment, but in production, no. So with wet, write everything twice, we then have the best practice version, which is dry. So don't repeat yourself. And it's exactly what it says on the tin. It's trying to get you to have a single representation for each value within your code structure. and then you want to reference that via variable or via some other form of technique via your IAC. You don't want to be repeating yourself, retyping hard-coded values within your code deployment. So when we think around Terraform, for example, you can have a variables.tf file, you can create a variable in there, and then you can have a tfvars file, have your values in your tfvars, maybe that be for development, testing, production, and you can reference that tfvars file and quickly swap out them values, but still use that single source of truth within your main.tf. Now imagine if you had to hard code values in that perspective, from that perspective, and you had to write out a development piece, a test piece, and a production piece. That's 3 times you've just done that. That makes you less of just more overhead, less efficient, and it becomes an absolute nightmare. Whereas if we start taking advantage of variables and we start taking advantage of other pieces or other techniques within our IAC, we can have a lot of an easier life. Makes us more efficient. Error handling becomes a lot easier. Changes become a lot easier. We only have to change it in a single place. That will then be plugged into where the Terraform or the bicep calls that variable. So for example, if you need to reference an IP address, that IP can be in 20 different places, but you've only had to make a change in a single location. So that's absolutely fantastic for us. And it just keeps us consistent as well. And it keeps that code consistent throughout. It's not, as I say, you're not missing off like single values on the end because you've copied it wrong or you've got a space in there, or there's just it's minimizing that room for human error, which we all know we're prone to in IT. So that's kind of the basics of it. But what I want to do is I want to go that little bit further and show you how we can implement that within Terraform. And what we're going to do is we're going to hop over to the corner now, and I'm going to show you what a wet piece of code looks like and a dry piece of code, and some of the techniques we can use in Terraform to operate within that best practice. So let's go. Hey everybody, welcome to the corner. So I've quickly put together 2 examples, so you'll have to bear with me. The Terraform in this example is not tested. It's not working in any capacity. It's a mixture of ChatGPT and HashiCorp's resource folder on their website. But the purpose of the video is really to demonstrate what a wet example would look like versus a dry example, and then maybe some best practice in terms of folder structure, etc. But as I was doing it, probably want to break that out into a separate session too. As I say, the main purpose is just to try and show you 2 different examples and what to look out for, especially if you're developing within Terraform and developing within your repositories, and think, I can change that, I can make it better, a little bit slicker, and reduce that window of opportunity for error. So with that in mind, let's head over to our wet example. So if you go to the HashiCorp website, you'll see this type of example, and it is literally this. It's developed within a single template. We've got the main.tf only. We can initialize that and deploy that. We've got a providers block in here, along with, as I say, the Azure RM. We've got our resource group. We've got a virtual network, a subnet, public IP, and Azure Bastion host, and some configuration stuff. Now, a lot of stuff is hard coded. We're not using things like data sources. We're not using any modularity. We're not using any variables. We're not using any Terraform techniques really to make our lives a lot easier. And I've thrown in a little bit of catch me out, because I think this stuff can easily happen. So as you'll see here, we've got things. Well, we have got an Azure resource group called example resources. And the location of that is in West Europe. Now, as we can see here, someone has made a change and they think they've made a change to the location of the virtual network. And they've gone East US. So they don't want to deploy in West Europe, they want to deploy in East US. And I can see they've also tried to change it here and here. What's the difference? Well, it's a space, no space, and a spelling error. So by manually changing this in 3 locations, they've also missed a location, so they've overlooked it. And yeah, they've made a couple of mistakes along the way. So little things like that, when we're hard coding values, we're opening up the range of changes. Now, if that was in a variable, we just have to make a single change to the location variable, have var.location in there, have a dev.tf with issue s in as the value, and say use this tf against this deployment, and it would filter through into the Terraform file and whoosh, work everywhere it's called with the same value. At least then, if it's wrong, we've only got to change it once. We haven't got to sift through currently 51 lines of code to try and find that error. Now, think about it as well. We're only deploying a Bastion service here. Now, if you are familiar with the CAF Enterprise Landing Zone on Microsoft, you know where the Bastion sits in that hub section. But then if you start thinking around virtual WAN, you start thinking about all the connecting subnets, all the peerings, you start thinking about express route, you start thinking around site-site VPNs, point-site VPNs, maybe a little bit of AD Connect in there on a virtual machine or whatever. Think about using the wet principle, how hard your life would be. You'd be writing everything a million times, changing things over and over again. And it just provides so much overhead for you as an individual or your team or whoever you're handing it over to. And it can become very problematic very quickly. It's very hard to scale. And it's just not effective for us moving forward, especially within a production environment. And yeah, we just need to try and stay away with it. Stay away from it. Sorry. As you can see from the example, if we're doing a little bit of testing, if I just wanted to test Bastion on its own, if I was getting familiar with Terraform, or I was just testing some form of functionality, then it doesn't really matter, because the outcome, as I said before, is we're trying to get that result from the deployment. We're not really bothered what it looks like on the back end. But going forward, as you can see, it becomes very problematic. And we only wanted to change one thing. Imagine if we wanted to change 10 things. How many times or how many iterations would we have to change? How many times has that been mentioned within the Terraform, and where have we got to go through? And we've only got a single file as well. Imagine if we had to go through multiple files and folders and Control F and find every single mention of something. Oh, I get tired just even talking about it, never mind actually doing it. So yeah, that's an example of wet code. If you see that and you think, oh, that looks like mine, go ahead and change it. So with the ugly example out of the way, I want to now try and show you a dry example. Now, as I said before, with my little disclaimer, this is not being tested at any capacity, but I just wanted to try and whip something up super quick just to demonstrate how that dry principle would start applying to Azure Terraform for us Azure people. So here we've got our root section. So at the root level, we've got backend provider. Again, that would contain your storage account. We've got a provider block. So again, in the wet example, we had this at the top. We can break that out into a separate section. We've got a Terraform tfvars and variables for anything required at that root deployment. And then we break that out into our environments. So hopefully we're operating in a dev, staging, and production flow. And then just so you've got a bit of visualization there. So under the dry example as well, we've got our modules. So I've only created the Bastion module, but we could go into that a little bit further. We could go into, virtual networks. We could have a compute element in there. Anything that you think you can
modularize and that you're going to be repetitively using throughout your deployments, get it in a module. Don't be writing it twice. There's no need for you to be consistently rewriting stuff, copy and pasting, etc. Let's get it in a module. Let's perfect that module, and then let's call that module within our deployments. So let's go a little bit deeper into this. So let's go into the module. Let's go and have a look at the main.tf. So as you can see here, I'm already starting to take advantage of things like data sources. I'm starting to take advantage of variables within Terraform, and that's absolutely the right thing to be doing. Again, a little bit of a variable there for the module, and then when we go into the dev section, so if we're deploying for our dev environments, we'd have a backend in there for our dev. Again, that this structure is kind of consistent throughout. So we've got a backend, we've got a tfvars. I haven't put the tfvars in actually. Oh yeah, I have just for the dev for this purpose. As I say, it's not a working directory. It's literally just for this example. But we've got a backend. We'd have a tfvars for each of our environments. We've got a main.tf, and then we've got outputs and variables as well. So in here, the backend, we'd have our storage count for our state file. We've got some tfvars in there. As you can see, I've just thrown some things in there. The resource group name, location, subnet ID, and then DNS name for Bastion. And then I've started to develop the main.tf for the development environment. So you'll see here I'm taking advantage of data sources, and then I'm starting to use variables as well, which is quite good. And then as you can see here, I'm just calling the Bastion here. So as you can see, I can do anything specific underneath the module. I can add any extra values, but for the purpose of the video, I just wanted to show you that you can use different techniques within this structure to provide a little bit more modularity. We also have separation of concerns as well. So for example, if we've got, I don't know, maybe a Sentinel piece in there for security, maybe we've got a V1 or peering or VNet for the networking team, or we've got maybe some, I don't know, Kubernetes or front end. We can maybe offset that to the development team, or maybe if you've got more of like a DevOps team with operations involved in the development process, we could offset that to them. It's not within some large monorepo where everyone's involved on a single file. That can get out of hand drastically. So we can really start implementing permissions on top of that. You know, you've got access to this, but not got access to this. You can't have access to the key vault because we don't want you to see the passwords. We can't have access to the storage account because I don't want you changing something for the state. We can really start to take advantage of the modularity within this structure. And it's scalable. As I said before, when you think about adding more and more resources into that single TF file, nightmare, absolute nightmare. Whereas this allows us to do that. We can build modules, and then we can call them modules in various different environments, and we can also plug in some variables and TFRs for them as well, which makes our job a lot easier, makes changes easier, simply from the location variable, the location value that I demonstrated before. And it's easier to maintain as well, much easier to maintain, and just makes it easier for you, your team, and any potential person that you're handing it over to as well. So things that we need to think about when operating in Terraform for that dry perspective: we want to be looking at modules like we've just discussed. We want to be looking at variables like we've just discussed. Any local values that we can do. Terraform workspaces as well is a good call to have a little look at. We can also take form of Terraform count, so we can create multiple instances as well, as I say, as opposed to saying create this, then this, then this. We can use count, and we can use that too. And then we can also use data sources as well, as we've seen. So some really good techniques to adopt that dry methodology when developing our IAC. So I hope that's been helpful. As I say, take what you can from that. I will break that out into a separate session on trying to understand the best possible practice for Terraform folder structure, because I feel that sometimes I personally have not come across anything that states this is the way to do it. And I suppose there's a load of ways to do it. So if someone can beat me to the comments and paste in something and say, this is the answer, awesome. I'm all up for learning as well. We're all here to develop. So thanks very much for watching. I hope you took something away from it. I hope you're not too scared. I hope you're not running to your boss now saying, we've got to change everything. But if you are, just do it quietly. Don't maybe go and make the changes with your team before grassing yourself up. But yeah, hope it's helped. And thanks very much for watching. Please like, share, subscribe, and I'll see you in the next video. Thank you.